given a series, the sum of an, a1 plus a2 plus a3, etc., let Sn denote the nth partial sum. So Sn is n terms of a1 plus a2 plus a3, however many that is. That's the partial sum. If the limit as the partial sum goes to infinity, so as we get infinite many of these little sums here, a1 plus a2 plus a3, all the way out to infinity, if the sum, the partial sum, approaches some value s, then we call the series convergent. And basically the whole idea of this is to see if an infinite series has a value or not. It seems unusual to talk about an infinite amount of numbers being added together being equal to something, as opposed to it just being equal to infinity, but it can happen. So we'll look at some examples where it does. So here's an example where it does. The series 1 over 2 to the n is 1/2 plus 1/4 plus 1/8 plus 1/16, and it continues on forever. If we begin adding them together and taking the partial sums, n is equal to 1, that's 1/2, then n is equal to 2, then we do 1/2 plus 1/4, it's 0.75, 0.875, and we'll continue going, and what we're going to notice is that they approach closer and closer to 1. They do not go out to infinity. They approach a specific value that it does not exceed. This is what would be called a convergent sequence. And we'll have a look at a divergent sequence. So this is very unusual because there are a couple of cases where it's, there are going to be a couple of things that are going to expect to. Here we can see obviously that if we were to take a limit of this as it goes to infinity, eventually these numbers are going to approach 0. So people can say, well, that's obvious. So obviously this sequence cannot be of infinite area because this approaches 0. Well, there is another case here. This is a sequence. It's kind of similar to this one up here, 1 over n. This is 1 over 2 to the n. So we'll have a look at this sequence. Let's see if we can deduce if it's convergent or divergent. So this goes 1 plus 1/2 plus 1/3 plus 1/4 and continues on forever. If we were to think of the limit of this term as it goes to infinity, it also approaches 0. This is going to become infinitely large, therefore this will approach 0, as in the example up here. So one might be led to assume that this is a convergent sequence as well, but it's not. And we'll look here why. So the sequence, pay attention to the left-hand side first. It goes 1 plus 1/2, and then 1 plus 1/2 plus 1/3 plus 1/4, all the way, continues on. What we're going to do is compare this to a different sequence. So on the right is a different sequence, 1/2, or 1 plus 1/2, and then plus 1/4 plus 1/4, which is equal to 1/2. And this would be equal to 2 over 2. So instead of 1/3 plus 1/4, we just did 1/4 plus 1/4, which is smaller than 1/3. So therefore this left-hand sequence is greater than the right-hand sequence. Continue on to the next row, 1 plus 1/2, 1/3, 4th, 5th, 6th, 7th, 8th. Here, same idea. 1 plus 1/2 plus 1/4 plus 1/4. But then on the right, we're going to do plus 1/8 plus 1/8 plus 1/8 plus 1/8, which again is equal totally to 1/2, in totality to 1/2. I guess that would be a better way of saying that. It equals to 1/2. So this continues to increase to 3 over 2. And this is for S8. Then S16, do the same thing. Now continue on with 9th, 10th, 11th, all the way to the 16th. And then we will do the same thing with the 1/16th. We'll put 8 1/16ths together, and it's going to equal another half. This right-hand sequence can be thought of this way, 1 plus n over 2. And here we can clearly see that as we go further and further out, this way on a sequence like this, when is this ever going to approach some limit? It won't. It's always going to get larger and larger and larger. This sequence, as we go further and further right, as we add up all of these little terms, they approach closer and closer to 1. It's convergent. This right-hand sequence will never approach any particular value. It's just going to keep getting larger and larger and larger. And this sequence here, as we noted over here, is greater. Here, instead of 1/3, we put 1/4. 1/4 is smaller. Here, 1/5, 1/6, 1/7, 1/8. Here, it's all 1/8. These are smaller than these terms. So if this left-hand sequence is larger than this right-hand sequence, how can this sequence ever converge? It's not going to converge. So this one is divergent. So it's got no area under its curve. So there's certain information we'll be able to know about this and not know about this. Mainly some certain calculus. Well, it doesn't matter. Later on we'll learn about what you can and can't do with convergent and divergent sequences. But just know for now that this series has no sum, while this one does.